This year's Pew Teaching with Technology Award recipient is Robert Talbert, Associate Professor in the Math Department at Grand Valley State University. Since 2008, Robert has been flipping his classroom by creating instructional videos and other digital content that students view before class, which frees up time for more meaningful learning experiences in the classroom. In addition to the flipped classroom model, Robert has been using programming and coding software as a means of reinforcing math concepts in which students construct their own knowledge as builders and makers.
Generally speaking, I'm trying to incorporate any technology that allows students to make things and construct their own knowledge about the concepts that we're learning, and also to access information at any time in multiple modes. Okay, for example, making videos for my classes to replace in-class lectures using the simple YouTube technology and screencasting technology. That's a technology I've been using for several years now to take my existing course lectures and demos and move them off-site onto a YouTube channel where it's free, can be accessed, can be re-accessed, rewound, paused, replayed, with the intent of having students get some exposure and construct some knowledge prior to arrival in class, which we can then use the in-class time that's freed up to do even more complex things. Some other technologies that play into that ethos would be just the simple use of a Google document, for example, to gather student questions about the material prior to showing up for class. So I know, based on their self-reporting, what the questions are going to be before we even show up for class, and that's where we start. I tell the students that I have some plans for the class period, but those plans go into place only after we finish your questions. With whatever time is left over after we discuss your stuff, that's where my plans come into play. Been trying to use more software that allows students to create and construct things, including programming languages, the standard programming languages like Python, for students to take concepts that are abstract and then pull them into the concrete by building instances of them, playing with those instances, and then going back and making abstract generalities out of those concrete objects. This is what mathematicians do. I mean, we play with concrete objects, try to see what the patterns are, what are the phenomena that are going back and forth between all these instances that we play with, and then try to make conjectures and then develop proofs for them. So I've been using software such as GeoGebra, which is a dynamic geometry software, but it also works really well for calculus students. It allows them to build examples of calculus problems that they might read in a textbook, play with those examples, and then make guesses about what the process and the answers are going to be, and then go back and work the calculus out. I'm teaching a couple of courses for that are intended for computer science majors now, and I've been teaching them the Python programming language alongside the course, just as a side issue. First of all, because I think they need to learn the programming language, and second of all, it's a natural test bed for them when they see an abstract concept, say involving set theory. Well, they can just write a program that generates certain kinds of sets and then see what are in common and play with these sets in a very real sort of way. So programming languages and simple communication tools like Google Documents. Another technology I've been using is clicker technology or classroom response technology. Sometimes in the form of the physical clicker devices that we have, and lately I've been using a web-based tool called Learning Catalytics, which basically takes a tablet, a smartphone, or a laptop and turns it into a clicker. So students will see questions that I serve out to them. They answer these questions by clicking or tapping on an answer, and I collect the data on my instructor dashboard. And I use this to help students kind of navigate difficult conceptual moments in a lesson. So I might feed them a question where it's a tough conceptual question that hits at a common misconception, and have them vote on an answer. Typically there will be some disagreement about this, and if there is, I'll say, okay, turn to your neighbor and discuss what you just said in your answer. And very often students will construct the right conception just by talking to each other. But the tool there, the technology tool, is there merely to enable the discussion and the interaction.
So you talked about using videos then to sort of flip the classroom, and one of your classes you have specifically then used that model then for actually, you know, if you want to call it flipping the how the students receive the material outside of class, and then in class using that time then to specifically address their questions and to work on problems. So do you think that your students are coming better prepared when they come to class?
Oh, absolutely. Simply because they weren't really coming to class prepared at all before, because I wasn't asking them to come to class prepared. Or if I did, I wasn't necessarily serious about it. I would say, read this textbook, pretty much assuming that very few would. And so now they're coming in, not necessarily experts on the material when they come in, but they at least have some strong questions about the material. They know exactly where their roughest spots were. And so they're not coming in as blank slates, having never seen the stuff before. So they're coming in prepared, very often in the sense of they've mastered some basic learning objectives and are ready for something more advanced, which is what we spend the class time on. But at the very least, students come in, if they've done the preparatory work, knowing what their questions are. And that's a really important place to be when you come into a classroom.
So is your impression then that your students like that model? I mean, how long have you been using that? And so far, what kind of results have you seen from it?
I've been doing the flipped classroom model since 2008, even before I came to Grand Valley in 2011. Overwhelmingly, the students are very enthusiastic about this model. I know this from course evaluations, from informal discussions, from informal midterm evaluations that I give, constantly asking for feedback on how it's going, and students are almost entirely positive, almost never negative about it. The students who do express some negativity about it, it at least opens up the opportunity to have some frank conversations about the nature and the role of the professor and the student in a classroom, and that usually ends up in a positive way. So yeah, students the students get it. I mean, students understand that this is for them. This is for their benefit, that there are certain things that they can do to help themselves learn, and everyone knows this. Every human being has the ability to learn things. Just ask a 5-year-old. Somehow that gets lost, it seems like, in the intervening 12 years before they come to the university. And so I feel like the flipped classroom is a way to sort of recover that essential humanity of the student, to really come back in contact with that ability to learn that they may have lost. And students get that, and they understand that, and it feels good to them.
So have you seen, along with that then, an actual increase in overall test scores, or typically are students' grades higher than from what your typical face-to-face classes teaching the same types of material would be?
It's kind of nuanced. I would say that the flipped classroom has significantly more rigor in it than a traditional classroom. And so grade distribution-wise, I haven't necessarily seen a big change. I think that the students are doing harder work, and they're doing well at it. They're doing better at it than they would in a traditional classroom. But because the work is more rigorous and more difficult, we're focusing much more on higher level tasks than lower level tasks. I think the fact that the grade distribution tends to be about the same. But I think the students are better. I think it passes the eye test for me. I've taught calculus for 20 years, and the last 2 years that I taught calculus flipped were the first 2 times I've ever had adequate time to have students explore concepts in class. Before then, it was always a push to get things done. We were rushing to get through things. I was not confident that students were really understanding what they were doing. In a flipped classroom, I have plenty of time for them to work together. I have plenty of time to answer their questions, to give spot lecturing if needed, direct instruction on demand in classroom, and do lots and lots of assessment, informal, formative assessment. And so I know that they're doing well with the material. Okay? But it's harder. It's harder for students to do this, and I'm asking students to do more. Okay? So I would say that the students who usually get A's in a traditional class still get A's in a flipped class, unless they found some way to kind of game the system and get by, in which case their grades drop. And I believe that's as it should be. Students who get B's and C's tend to get A's and B's now, because they're getting multiple inputs from different people. I mean, they're learning on their own, they're hearing me lecture, they're getting one-to-one interaction with me in the class that they didn't get before, they get multiple-to-one interaction with their friends in class, and so that multiplicity of inputs really helps them. Students who got D's and F's before still get D's and F's. So it tends to sort of keep the highest achieving students where they're at, move the middle of the pile up, and move the bottom of the pile down, is my observation with that.
So is it practical to think that all classes then could use the flip model, or are there some types of curriculum that just simply aren't going to transfer?
I think all types of classes can benefit from thinking about what can you have students do to prepare for class in a structured, rigorous, informative way. there are certain situations where I would not necessarily feel comfortable with a flipped classroom. For example, if I were teaching in the summer and it's in a 6-week format, that is a lot of preparation, and I just don't know if the cognitive load is really there for students. But as far as disciplines go, I have worked with many faculty in many disciplines and workshops and one-on-one consultations about the flipped classroom, and I've never come across a discipline where this wouldn't possibly fit. It really has to do more with the time frame and the format, I would say, more so than the discipline. And you'll see the flipped classroom in many different disciplines, interesting locations like American Sign Language and dance and wood shop and nursing and physics, and all these places have places where have parts of the content where students can benefit and do benefit from working on their own prior to coming to class, and then shifting the focus of class time to practicum types of stuff. So, yeah.
Now you also talked about other types of collaborative tools that you're using as part of your courses, including the learning catalytics response systems, as well as Google Docs. Are you, as part of that, it sounds like you're able to get more accomplished than in class when you're using those tools versus not having them available to the students.
That's right. Because I'm having students kind of give me some formative assessment in their questions before we even show up to class. It quite often turns out that there are items of content that I don't have to even worry about in class, like very basic definitions. I don't have to spend time writing on the board what the definition of a term is. They have that, they've seen it, they've read it, they've built some examples of it through their pre-class practice, so that's 10 minutes of time I have to do something else. And with them giving their questions to me and their concerns and comments prior to class through just simple collaboration on a Google document, I can target what we do in class. And so it's quite lean, it's quite efficient. There's not a lot of fat on what we do in class, not a lot of fluff or wasted time.
And so what do you enjoy most about using technology in your classes?
Well, first and foremost, I'm a nerd, and I just like technology in general, and so anytime I get to use it, I enjoy it. But I think that for instructional purposes, the thing I enjoy the most is the sort of position that it puts students into. It turns them into makers, and I'm very into the sort of maker ethos. That you should build something to understand it. Okay, if you're going to be a computer science major, you should really build your own computer, for instance. Okay, if you're going to be a mathematician or a math major, you should really be practicing building the things that you are going to be working with. And this puts students into a position. Using technology enables students to build things. Okay. Examples of an optimization problem in calculus, or a Python function that generates truth tables for a discrete math course. And the process of building really helps students to internalize those concepts. And it's more fun, and students don't realize that they're working because they're having so much fun building the things. So that's what I really enjoy. It's the kind of students it turns them into, not just passive recipients, but active constructors of what they're learning.
So obviously, the use of technology is here to stay. I mean, it's the future of education. Do you think is going to be predicated then on the use of technology? I mean, there's still a lot of discussion, especially in the K through 12 schools, that incorporating technology into the classroom. And you've got to be very careful about its use, how it's employed, and how it's incorporated as part of the curriculum. There still seems to be a lot of positive talk about it, but there's always going to be detractors.
Sure. I think what technology has done is it's shifted the narrative away from, we no longer believe that teaching in a classroom is about disseminating information only. And that's the way it had been for hundreds of years prior to maybe just as early as 30 or 40 years ago. Any ensuing discussion about technology will presuppose that we don't do it that way anymore. We don't spend time in the classroom merely disseminating information. Okay? It does change the narrative to say, how can we use technology in a smart, student-focused, scientifically sound way to help students better construct their own knowledge about the concepts that we're trying to teach them. And how do we do that in a way that's simple, that's cost-effective, that doesn't entail sticky issues like network security or online presences or whatever. But those are the kinds of questions that are happening now. That's the kind of questions that are going to be still present moving forward. The question is not going to be, should we use technology in the classroom? It's more like, how should we? And those are very good questions, and the answer is not use as much as possible necessarily. It's use it in a smart way, but technology has definitely changed the narrative forever about what a classroom is for.
And it's obviously changed the shape of what we think of in terms of a traditional math classroom and how those math concepts are learned and presented.
That's absolutely right. Yeah, I think previously, mathematicians have always known that you have to do math to learn math. And yet we have been teaching math in such a way that there is no doing, and the only doing takes place outside of classroom, outside of the supervision of the instructor, where students are most likely to fail and not be able to get help. And this just seems, and we've had sort of a weed out mentality in mathematics for so long. So, well, if you can't cut it at home with this hard material, maybe you shouldn't be a math person. And maybe that's not the right narrative to have with students anymore. Maybe the narrative is, I'm a consultant to you, and you are a client, and you want to learn math, and I want you to learn math. And so we're going to construct and design our classes so that we're working together on the hard stuff. And in order to do that, you don't have time to do both the easy and the hard stuff in class, so hence the flipped classroom model comes into play.
Well, and especially considering what types of skills now students are going to be required to have once they've graduated from college and going into the workforce. I mean, you would think that having that opportunity to be able to construct that knowledge on their own, to be able to work on those problems collaboratively. I mean, that's all going to assist them in terms of just or empowering them once they do enter the workforce.
Absolutely. Yeah, there was a great study done recently where the researchers brought in some CEOs and HR people from major engineering firms and asked them, what exactly do you want from engineering graduates? Say 1 year after graduation, 5 years after graduation, 10 years after graduation. And a long discussion ensued over several days, and not a single person ever said anything about content knowledge. The only thing people talked about were the first year graduate needs to be able to come in, hit the ground running, and pick up our system and get up to speed quickly without a lot of hand-holding. The fifth year person 5 years out needs to be contributing to the system and managing our system and helping the first year people come along. The 10-year people need to be leaders. And so there was no question about this person really needs to be able to calculate a double integral in polar coordinates. And nobody ever said anything about that, or even about engineering knowledge. It's assumed that everybody has the content knowledge. What the really desirable skills are the ability to learn on your own, to work collaboratively, and to be able to handle problems that may not even exist at the moment. If we only teach the problems that do exist, then we're not preparing students for the next 10 years where the change is happening so rapidly. We don't know what the problems are even going to be in 10 years.
So as far as the future is concerned then, what are your technology plans? Are you looking at something new or different, or are you trying to just continually evolve then the types of technology use that you are employing in your classes?
Sure. First and foremost, I just want to keep perfecting my craft. I'm not all there yet. There's a lot of kinks I still need to work out with the way that I implement the flipped classroom. I don't think the flipped classroom is not going away for me. I'm just gradually, every time I get a new course prep, I approach it as if I'm going to flip this, and so I just go through it. Technologically, not all the courses that I teach have a really good body of out-of-class ready material like screencast or videos, and so that's one thing I'll have to sort of work on in the future, is building up or curating some really good materials for those classes, or creating them, one or the other. Apart from that, I really want to keep exploring this idea of coding and computer programming in the mathematics classroom. I really feel like students need to be, in a math class, need to be able to code and write their own code, whether that's programming formulas into an Excel spreadsheet, or writing a Python program, or working with a functional programming language, which is something I've been thinking about with one of my courses, is switching the programming paradigm from imperative to functional programming. This is just another aspect of the building the maker ethos that I really want to bring into class. I feel like programming and mathematics used to be one and the same. They kind of drifted apart in the 70s and 80s. Now I feel like they need to come back together again. So even in something like calculus, I want to see how we can start building in sort of a data science approach to calculus, which seems to be more relevant to the kind of time that students are working in right now. So I'm just beginning to think about that. And I think it's going to be an exciting thing to continue to develop over the next 3 to 5 years.
And as far as Grand Valley is concerned, do you see? It's a great supportive environment here, especially for faculty to try new things, to explore the use of technology, and obviously, do you see that continuing?
Absolutely. I've got nothing but support from my dean and the provost's office and my department chair and my colleagues, and I would not be sitting here